So welcome everyone to the second session of this municipal and municipal official and planning audience webinar series that we're conducting through Cornell Cooperative Extension, Pennsylvania, and some other partners that are bringing together some experts on these topics. And tonight's is on environmental concerns around the solar panels themselves, some of the balance of systems components, and also on the construction site overall. So some of the stormwater issues and things. So we've got Jason Mulford from Ag Markets and Annick Anctil from University of Michigan. And so I'll let them introduce themselves and we'll jump right in. So if we want to get started, I know we have a lot to cover. And like I say, we'll be taking questions toward the end. Pop them in the chat at any time, and we will get to them as we're able. Thanks, everyone. So Jason, if you want to start us off.
Sure, thank you very much. I'm going to share my screen now. Okay, how's that look to everybody?
It's good.
Okay, good job. Okay, again, my name is Jason Mulford, and here's my contact information. I am the Ag Protection Unit Manager at the Department of Agriculture and Markets, and part of that, those responsibilities entail reviewing of solar projects and in accordance to Ag and Markets law and public service law. For those who aren't familiar with Ag and Markets, just give you some of the major divisions here at the department. Don't tell council I didn't include them, but these are the major ones. I am part of the Land and Water Resources sector. And in Land and Water Resources, we have generally some main units. And I include farmland protection and agricultural districts as part of the Ag Protection Unit. The Soil and Water Conservation Committee and its staff and technical staff are a large percentage of the unit, but today we're just going to focus on what I officially manage. You may be familiar with the Soil and Water Conservation Districts. Highlighted programs in the Ag Protection Unit and Ag Districts. The 305A review of overly restrictive local laws is a popular one that we deal with municipalities if manure storages, things of that nature. Any citations on a farm, we help determine if they're overly restrictive or not. But today we're going to focus in on notice of intent more. Right. When we discuss agriculture and markets involvement with solar development, there's different categories. When we talk about the on-farm equipment to a farm, that's typically offsetting that 110% of that farm's needs. Anything above and beyond that, then we start to talk, that's a distributed energy or commercial facility. This is a CAFO, and you can see the solar panels there.
Jason, we had one request. I don't know if you're able to look into, it sounds like your volume is quite low, so it's coming out low, even if we max out our volume.
Okay.
If you could increase that, thank you.
Let me see what I can do here.
Thanks.
Maybe if I just sit a little closer, maybe that'll help. Okay. Seeker projects, typically going through local review. sometimes if they're within the ag district, they have to go through the notice of intent. This is ag and markets law or ag district law 25 AA 305. And a lot of folks don't know about this program, and that's why we're putting it out there as a reminder. And typically, this is required of any state agency, or in this case, if it's NYSERDA, that's funding these solar developments, a public benefit corporation. If they're using state funding, then NYSERDA has to submit a notice of intent to Ag and Markets. They're not, in the traditional setting, this law was created for, say, sewer water facilities that the municipalities were utilizing public dollars for DOT projects, etc. But I don't think the developers of the law ever intended this to cover solar, but yet here we are. So NYSERDA, they award contracts with these corporations and pay for energy, and therefore assist in the construction by securing, revenue. So here, a public benefit corporation with the interest of more than 1 acre, in advance a grant loan or other funds. 65 days prior to that award, NYSERDA has to submit this notice. And I wanted to draw your attention to that includes the county ag and farmland protection boards. Typically, the county planning is directly associated with that, as well as soil and water, Cornell Cooperative Extensions, and so on. And then once the department determines that the review is complete, then we open up the floodgates for ag and farmland protection boards, as well as others as statutory parties to offer comments. And then we proceed to a commissioner determination to identify if it's an adverse impact to the agricultural district. And I think that's the key that I want to bring to your attention, is that this is for agricultural district properties, not zoned agricultural district, but locally adopted, state certified ag districts, and how they impact that said district. Some years ago, I'll say 2022, because it's entitled that, the department hosted a farmland protection working group through state law. We were mandated to, and developed an interim report. And in this report, NYSERDA was able to identify some history of their program, which we are in close contact and consult with. Some highlights here is in 2019, this is when solar really started to take root. And in 2019, we were able to work with NYSERDA to require the adherence to our construction mitigation for projects to follow, which includes, not only planning, but the construction standards, to restoration and decommissioning activities, which we'll talk about in a bit. In 2020, this was amended so that there was an option for an ag mitigation payment. It's a calculation that it's a fee mitigation that we collect in a fund, and that's only when there's more than 30 acres of mineral soil groups 1 through 4. That's translated to be the best productive grounds that New York has. So with the construction guidelines or the construction mitigation, we began to look at these projects a little more closely, and was able to ask a little bit more questions of how they're going to operate or construct these facilities, primarily construction standards for like topsoil segregation, and as well as a little bit of siting. We'll discuss that a bit. This I chose this picture here is it may be hard for you all to see, but there's a section of let's see if I can use this highlighter or laser pointer. There's a section of field that I'll call off-property abandonment. And because the access is blocked, and then there's all sorts of plantings here. So not only is there probably going to be abandonment within that setback area, the property line changes hands here, and there's no access to this. And these are the types of things that we ask developers and NYSERDA to, well, minimally answer the questions. Have you considered relocating this so that this still can be worked? Let's see. You know, get rid of my laser to move on. Another consideration with construction mitigation is topsoil or soil protection. These are photos taken recently of projects in construction. These are typical photos that we see on a regular basis. Compaction is a real challenge. We try to encourage low PSI vehicles to reduce rutting, but compaction is an issue due to the changes of hydrology, increased runoff potential, infiltration capacity. Decommissioning in the facility is near impossible, especially considering the type of equipment required. Could it hit the infrastructure installed? But it has happened. Immediately, decompaction is typically reserved for outside the fence facility until decommissioning. There's typically drainage impacts, especially with subsurface drainage. All those posts pin cushion that field and generally will strike water. So we'll find situations with that, and I'll show you a photo later on. Long-term issues, we're concerned about the chemical changes in the soil related to that long-term saturation. They'll turn into a hydric soil eventually and lose the productivity. Most commonly is the mixing of the soil stratification, basically deep rutting. This woman is, average height, but, we have ruts up to her thigh, and you wouldn't expect that for a development that's supposed to be low impact, but this is real. This is what happens. And so we're concerned about the loss of the agricultural resource, mainly in that topsoil layer, not only for potential agrivoltaics, but also for that decommission potential, that return of agriculture. Citing considerations, and I'll run through a few site plans that we received recently. But first off, we wanted to say that AGM has really limited influence regarding the array location. And that's mainly because a lot is predetermined. By the time we get it, there's already setbacks considered. there's limitations on what property that developer has in control, regardless of how many properties the farmer may have. Obviously, seeker's underway, and some of these projects already have approvals by the time we get them. Interconnection with utility is already secured, and the landowner, of course, has preferences on where to build these facilities. But we have to keep in mind that we react to NYSERDA's filing, which, NYSERDA's interest really is what enables the projects or the project investors to move forward with such a project as this. But keep in mind, these are generally mature projects. Therefore, what what I'll try to bring to you at the end of the presentation is even more important, to get our involvement as soon as possible through the seeker process. This facility here, we had questions concerning the point of interconnection, which is in a field opposite of the road that's circled at the top of the screen, and also the large gap of between the facility and the vegetated screening at the bottom of the screen. This site was nearly 100% on the best soils, and we had some orphaning issues. It's difficult to see, but that is encircled area is all active farmland that will be difficult to get to with any equipment, considering the wetlands and all the remaining lands that aren't developed. Also, had a significant amount of vegetative screenings, which I understand that nobody wants to look at these, but that takes away from production ground as well. Some sites are cited on preferable loss of agricultural land, the lesser productive lands. However, a lot of times they require the most impact grading, and particularly the severity of grading on this site was extreme, and our comments related mainly to topsoil segregation and the phases of construction, where the most of the cut didn't match up with a balanced area for the fill. Just kind of a common sense. You have to put it somewhere. Well, it got better, but those comments were addressed to the municipality as well, that we have specific concerns, and we brought it to DEC's attention for stormwater. And we're concerned about the alteration of hydrology. They did do a positive where they keep clean water clean, but I don't know. We're going to have to address that at decommissioning. Discussing certification of the notice of intent. Before the commercial operation date, and NYSERDA cuts a check to these developers, NYSERDA submits a certification to say that everything was built according to plan. And at times we have some issues with that. So now we have the capabilities to do site visits at the end of this period and verify that these things have been built according to plan. We have noticed a lot of changes, and no amendments have been filed with the department. And we also questioned to the municipality if any building amendments have been filed with them. This particular site has a differing collection line. And increased it impacts to a field that was previously going to be untouched. So we address that with NYSERDA and the developer. What can be done at this point? Not a whole lot, but we force them to make an amendment. This also had much more extensive grading. You'll see that the vegetation was denuded from a lot of this site, and that was they kind of went beyond their means that they said they were going to. Also, the laydown yards needed to be restored before we would approve the certification. This site had a 200-foot deviation in the facility, causing orphaned areas in the back portion of the facility. And this was an undetermined impact that the department, didn't have we didn't consider, so would our determination have changed? It would at least mention this. This happened to be on some poorly productive grounds, but it definitely would have, we would have requested that to be pushed back. How this moved forward is still being under investigation with the town. To even know if they even knew about it. And from what I understand, a lot of the towns don't know of these changes. This is causing a little bit of problem of getting these final payments out. This is a project where we're having a drainage impact, where the local soil and water has been instrumental in getting a plan of work together. And we've been in conversation with NYSERDA and the developer to fix the drainage issue and incorporate it into the existing drain lines. But this is a boil from subsurface drainage poking out of the ground and inundating the neighbor's field. I'm happy to say everybody's working with each other, although it's taking quite some time. We're getting this resolved, and the certification came in to say that this was built according to plan and there's no impacts other than what's being what was proposed. Part of the construction mitigation is a 2-year monitoring plan. And none of that monitoring ever reflected this. So I'm glad we had the opportunity to go out. Decommissioning highlights, ensuring topsoil preservation has occurred. And where it's, at construction, where was the topsoil being spread, if those records were retained, if we can put that back and say where the roads were or where the transformers were, or do you have to bring in material, invasive free topsoil? What's the regrading potential? We do have significant grading on some of these sites. And is it necessary to put it back, or is it better for the ag producer to leave as is? That's something we're gonna have to deal with at this time. A lot of topics on decommissioning relate to the retention of the fence and access roads for the farmer. In the case where the sheep industry really does take off, that fence would be nice to maintain that operation. We would consider that depending on where we are at that time. Vegetated screening removal. A lot of times that's not included in decommissioning plans. If everything else is being removed, we want the screening removed to bring it back into active ag production. Collection is always an issue in the plans. If it's outside the array, according to our mitigation, it should be buried more than 4 feet, and then it can be abandoned according at the time of decommissioning. It's deep enough that it wouldn't pose an issue. If it's less than 4 feet as inside the array, it's full removal. I tried to be cute here and say, we're missing a photo because we haven't gone through this process yet. and I don't know if I will in my career, but these are the items we'll be looking for, as well as adhering to the construction mitigation. Agrivoltaics and co-utilization. Alert everyone that the department looks at this generally as a mitigation. Is it instead of fee mitigation, can agrivoltaics be utilized for in place of fee mitigation at times? How we do that, we think of it as it's gotta be relative to a farm operation. What is the farm operation? But a commercial enterprise that produces crops, livestock, and livestock products. If you just have somebody out there, pasturing sheep, and doesn't sell any agricultural product, in our view, that's biological lawnmowers. That's not a farm. We have to have a sale of a crop. As far as crops and livestock products, we have a variety of them. And here I have some highlighted that are typical for agrivoltaics. But the key is it shall not be limited to the following. We do offer some flexibility, but it has to be part of a commercial operation. Field crops and hay has been more of the progressive agrivoltaics that we've approved. Also, we do have pasturing where sheep has been the main focus of the past few years, but cattle I should have highlighted. That is starting, as far as pasturing dairy animals primarily. We have some great work being done in that area to elevate panels, but I don't believe it's ever going to be at commercial scale. It's smaller operations. A lot of vegetable truck crops, things like that, but it's a very it's limited to those smaller community scale sites. Apiary products, we feel apiary is already a co-use. You can have an agricultural crop with apiary, so we're not biased against bees, but we can have a forage crop with clover in it. You can have all kinds of crops that bees would be attracted to. So that has a limited aspect to agrivoltaics. I showed this one picture before, although we had some certification issues with it, but the farmer is, on both of these cases, the farmers are producing hay forage, dry hay, and to the point where they're spreading manure and using typical agricultural equipment to do it. They're single axis trackers and can be moved so that they could mow the crop, ted bale, and amazingly enough, spread manure with an open box. Advice for you folks, and I'm not going to claim I'm a seeker expert, but just some highlights for you all. In the initial process where you're defining what the project is and determining, is it a type 1, type 2, type 3, type unlisted action, there is a provision to identify if the project's located in an ag district, and that's typically in your EAF anyways, but also if it's going to comply with the subdivisions 4 of section 305 of Ag and Markets Law. And that's what I've been covering is the notice of intent process. The tricky thing is sometimes those state fundings aren't identified yet for projects that's going through the initial seeker process. So I'm encouraging municipalities to ask the question, will this be funded by New York State? Will you have a rec contract? And if so, this is an avenue to say, we want to hear what the Department of Ag and Markets has to say. And more importantly, maybe the local Ag and Farmland Protection Board, who is a statutory party. The department has a statewide perspective, and the local farmland protection has a more of a community or a county perspective. So that's part of the reason why we have them as a statutory party. We will be notified, we hope, of the seeker process, and we'll remind you of that. But in the case we aren't, which there's several times that we're not, we encourage you. Now, as I said, it's the EAF should identify that if a project's in an ag district where we have the right to comment on it. If it doesn't, you can always double check through what we call as the Cougar georeferencing system. Cornell University IRIS program monitors and maintains these records for us. So the question is the proposed solar facility, are they constructed with New York State funds? That's a hard question. You know, are they being constructed with New York State funds? No, but they're being encouraged with New York State funding. And so that's why it's a required notice. Also, the REAP program through USDA, they don't necessarily have to file with us, but they definitely want our input. USDA has contacted me personally, and similar with the USDA economic development monies for sewer and water projects. This is very similar, where they want to have that state input on this program. So we'll run through this process and give it to them. Okay, in general municipal law, and this is something I learned of recently, the county has a potential to refer to the local municipality for any projects that they have an interest in. So the proposed action, if it impacts a county, and I'll say, county park, county highway, etc. Well, a locally certified ag district is a county action. So this is where the county has an interest. And so it's on behalf of the county, they have that opportunity to advise the local municipality on such plans, the review of site plans. And a lot of times, the county will be looking to us to give them our perspective on the plans. And at this stage in the game, being so early, it may make more impact, on micro-siting a facility on a particular property. Things aren't set in stone as much at this time. And so that's really the most benefit that we can have, is if we get into the process much earlier. So what else do I have? Well, that's the end for now in a nutshell. Let me stop sharing. I try to skim over the program as best I could in a lot of time. I don't know if I'm over it quite yet, but
Well, that was great. Thank you. Yeah, I appreciate it. We have one question I'm seeing in the chat, if you want to just address it now, and then we'll jump to Annick and have a lot of time for combined questions. But there's one: do you or would you ever review projects prior to construction at the request of towns?
Yes, we have. And we always caveat that to say that this may need a further notice of intent that would follow up once addressed by NYSERDA, but absolutely.
Right.
And that, keep in mind that we have limits on what we're able to do. We're tied to the ag district, but by all means, send us something and we'll comment.
Thank you. And like I say, we'll have more time for questions at the end. Keep putting them in the chat or save them for that time. And my apologies to Annick for not introducing her even in the slightest in the beginning. I meant to do quick introductions of both presenters and also for saying she worked at the University of Michigan when she works at Michigan State, where she's a researcher. So my apologies, but Annick, please go ahead and introduce yourself and jump right in.
Yeah, no worries about Michigan. I'm kind of used to it. Uh, yeah, so I'm, as was just said, I'm Annick Anctil. I'm an associate professor at Michigan State in civil and environmental engineering, but I also have an appointment in AgBio research because some of my research has to do with quite a bit of my research has to do with the impact of solar on agriculture. I'm also the associate director for the Michigan Industrial Assessment Center, so I know the state pretty well because of that. So I did study, I'm originally Canadian, but I did my master and my PhD in New York State. So I went to Rochester Institute of Technology. So I do know the state quite well. And then I was a postdoc at Brookhaven National Lab. And there I oversee like the construction of the Long Island solar farm. So I did the environmental impact assessment of that project and looking at on the impact and how to better design solar arrays. So that was in 2011, 2012. So it's been a while since I've been working in solar. I also worked with First Solar on their recycling process. Then I moved to Clemson University for 2 years, but I've been at Michigan State for over 10 years now, and as part of AgBio research and also the environmental science and policy program. So really, I look at like better designing and the impact of solar, and also the aspect of policy and how to better regulate energy projects. So I do work a lot on my conference. I do work on like sustainability standards, and I do a lot related to energy research. So some of those standard here or specific to solar, and I'll talk a little bit more about those in a few minutes. Okay, so what is my research about? So most of my research is about like addressing some of the general public concerns, mostly about solar because that's what I like most, but I also have project about the wind and other type of energy. So a lot of times people come to me and ask questions about like toxicity, if there are concerns about noise or any waste issues. So those are area where I've done a lot of work in the past. My expertise is mostly in life cycle assessment. So I look at every stage of energy production. So for solar, I've done a lot of work about like mining, where is the material going to come from, like the impact of extracting the material processing. So here in Michigan, I'm actually really close to Hemlock Semiconductor is like 1 hour north. So they are the main producer of like silicon for solar panels. So I've worked with them looking at their process and how to make it greener. And then like how we can improve manufacturing, use space, and end of life recycling and so on. So in general, I look at existing technology, but also at future technologies. Wanted to introduce a few existing programs that might be of interest to you if you want to know more about like solar and sustainability. So at the international level, there's the International Energy Agency Photovoltaic Power System Program. So and there's a specific task which is called like PV sustainability. So and they publish a lot of report looking at different aspects of solar. So I don't think this is they publish quite a bit of things. So like there are fact sheet about like resource use or how to do life cycle or the impact of recycling methods and so on. And this program is led by Garvin Heat from the National Renewable Energy Lab. So the US has kind of always been the lead in that sustainability effort for solar. So if you just look at the IEA PVPS program, the task 12 is all about like solar and sustainability. In terms of standards, so I do work quite a bit in ongoing standard efforts, both because I kind of represent the general public and interest. So one of those is called the EP program under the Green Electronic Council, Global Electronic Council. They changed their name, I guess. And they just published this new report about the state of sustainability research like last month. So that's a pretty up to date, like what we know, what is unknown about solar. There is actually like two criteria. I'm not going to go too much into detail about that, but there's the ultra low carbon criteria. So like those modules that have been certified under that criteria means they were manufactured with like greener electricity, so they have lower embodied carbon. They also have like a more general criteria about like what would make a sustainable module. And this first criteria, I was part of the original team, so I think we finished that in 2017 or 2018. But we just recently, like on Monday, we started updating the standard. So right now we're updating the standard for changing some criteria, mostly in terms of like materials or toxicity concerns. So I'm saying that because that means manufacturers of module can get their products certified to ensure that they meet certain criteria. There's also a lot of criteria work being done right now by SIA, the Solar Energy Industry Association. So these two were just released, I think, last week. And you can see there's other ones in the work. There's actually another one that is not even there that I'm on, which is about like recycling and like how recyclers will need to be certified to be able to accept solar panels. So, but they are trying to put certain standard ways of and to ensure quality and also control in the industry now that it has grown quite a bit in the US. Okay, so going into solar, a lot of the work I do is mostly focused on the PV module. That's where most of the concerns are, but I want to kind of take a step back and talk about like the full system and some of the concerns I've heard or I need to address, and I'll talk a bit more about that. So some of the common concerns about the modules are related to like toxicity. Then you have your module, you need to combine kind of electricity that is being produced, and you need like an inverter, like multiple inverter in a large system and like transformer. So some common or increasing concern about those equipment is the noise from the inverter. And then there's a few not really common, but I think increasingly ask about like the toxicity of the other components, in particular the like the structure. If you have like steel, if it's galvanized steels, there are some people that worry about like zinc. And recently there was some about like chromium, but that's really not frequent at all. And in general, one of the main concern that we hear about is just the aesthetic of the system and people not wanting to see it. So I'll start about like the inverter noise. So inverter will make noise. That's just part of how they work. So it's kind of a low frequency like whining, high frequency whining. And the bigger the inverter, the more noise it could produce. There are standard about like how much noise inverter should be producing. I've put the table there. That's the NEMA ST20 standard. So maximum should be about like 67 decibels. So it's not really low noise, but what is important to know is there are ultra low noise transformer that exists. So like if that's concerns, if you're building a system close to houses, there are ways of choosing transformer that are better than others. Also, if a big part of the noise is not necessarily just the transformer itself, it's some of the cooling system. If you have fan, for example, or other parts that can be moving. So if you don't do regular maintenance, that's one way you're going to increase noise on your inverter. Also, in general, like noise shouldn't be an issue in solar if you've designed your system properly and you've planned where you're going to put your transformer versus where people live or where people will like the distance to it. And also if you've put like this one as like pads underneath to reduce vibration, or if you put some sound barrier, but usually just your plans should block most of the noise from the transformer. So I'm mentioning it here because in Michigan it's becoming like an increasing issue in terms of noise. There's been quite a bit of complaint about it because of a certain choice of inverter. But again, you can choose transformer or ask for transformer that are lower noise, because as we build bigger capacity farm, there's more chance that those larger inverter, if there's like, depending on how many you have, like they will make more noise. In terms of like the aesthetic, like there's different regulation requirement depending on state. So I can talk mostly about Michigan because that's what I know more here. But like the main reason we do it normally is like for aesthetic reason. But like if we plan correctly, we can actually improve the environmental benefit of the farm. So like that provides additional carbon sequestration. And before me, there was a lot of discussion about the impact on the excessive water and hydrology change. So if you choose the right plants, you can increase the root and reduce soil issue in long term if there's extreme rain events and so on. You can also and prevent like erosion, or you can improve like soil health. The thing we need to be careful is like it was not an issue early on when there was just a few solar farm, but there seems to be an attraction for everybody liking the same kind of species. I would say in Michigan, everybody wants a Christmas tree or like any type of tree that looks like Christmas tree. And it actually created a big issue in the state. Like it's made the Christmas trees super expensive because everybody wants to use them for solar farm. They're also like not ideal because deers really like them. So it's creating two issues because people choose a species not because it's the ideal species for the site, but more because that's what they like or they would like to see around the solar farm. Also, this one is just like one row. We've seen more and more places where now there's like 3 rows of trees. So it's excessive number of trees for what you're trying to kind of block the view. So there's other type of plants you can choose that would be better suited. You want to make sure you're not planting trees that will attract unwanted wildlife, and particular deer in Michigan. And I know New York has also a lot of deer. You want to choose plants that are native, but also it's good to use like multiple species so that you have a more resilient system, and it's better for also like your biodiversity and attracting birds and other species around there. So there was some mention before about pollinator habitats or bees being part of like making agriculture. So that's an area where Michigan State actually did a lot of work. So we also have like an extension office, and part of this guideline for making pollinator friendly utility scale solar project, or that pollinator habitat scorecard was designed by the Michigan State Extension. Like, so Charles Gold is pretty involved in that. So it's good for the health and habitat, same thing as the other plantation you would do around a solar farm is good. This is good also for the soil. It's good for honey production and so on, and for stormwater runoff. But some of the challenge is some of the solar array right now, in particular, if you have like a tracking system, you get like a lower panel height. So it's getting a little bit harder to have pollinator friendly habitat that are really low height. In some area, that might be an issue with like the amount of water you get. That's not an issue in Michigan most of the year, except like in August and so on. So, but in other climate, that might be an issue. I would say the main issue is to plan for long-term management and maintenance. So in Michigan, we've put like there's a rule about you need to put a pollinator-friendly habitat when you build solar array, but there's not necessarily a need to maintain or make sure that it's working as plan. So a lot of that's something one of my students have been looking at is how those pollinator habitats are looking after a few years. Like, are they still producing, or are they just abandoned? Like, yeah, are they useful or not? So you don't want to just build it. You want to make sure that it's being useful for at least a few years of the project, if not all the 25 years the project is supposed to last. So you have the same thing in New York. You have a pollinator-friendly solar bill. So this is something that has been encouraged quite a bit. Okay, I'll move on and go a little bit more in the solar module itself, because that's my main expertise. So I'm gonna probably run a bit quickly, but I want to cover a few things and hopefully answer some of the question you might have about like solar panels and some of the toxicity concerns. So in terms of like what is the solar panels and what we're installing, I would say almost all of what we're installing is silicon. So this is global. This is not just the US, but like if we were looking at the US, only a really small portion right now is still like cadmium telluride. So that would be modules that are produced by First Solar, not very far from here in Ohio. But the very big majority of what is being installed is silicon, and it's mostly monocrystalline silicon. We used to have polycrystalline, but now we can make better efficiency modules at at lower cost. So most of the market has moved towards monocrystalline silicon. So what is the difference between these two type of modules? They are pretty different in what they contain, but in both cases, the main material for a solar panel is actually glass. And this fraction here for silicon modules, there's a range here because module can have like a front glass and the back sheet used to be mostly plastic, but the industry has been moving more and more towards like a glass on glass module. So like the amount of glass you get in the solar modules is increasing. And then what the difference is silicon or the cadmium telluride. This is like the active element that absorb the light and produce electricity. So, but it is a really small amount of the amount of material in the module. In particular, I'll start with the cadmium telluride. This is like less than 0.1% of the material in the module. So we're using a really, really tiny amount of the active material. Like most of what you have in a solar, like in a CAD-TEL module would be glass and a bit of plastic to keep the two pieces of glass together. And then both of those modules would have the same junction box and like cable that will link to the rest of the system. For a silicon module, as I said, normally you have like a glass. You can have a glass on the back too, or a plastic back sheet. And then same thing, you have like some plastic layer to keep the silicon cells to stay there. On the cells to make the contacts, you have usually like silver and aluminum mixed with it, and sometimes a bit of copper, but like all of those elements are in small quantity. You get a little bit more aluminum in the silicon modules if you have a frame here. So still like most of the silicon modules have a frame. There is more and more frameless modules to reduce the cost, but the frame is still pretty important there. So if we start with the cadmium telluride, some of the concerns is about the toxicity because well, cadmium is toxic and tellurium is scarce. So at the same time, that's a good thing because if you're working with something that is really scarce, you don't want people to dispose of it. So when First Solar developed their technology, they also at the same time developed their recycling method. So it's actually cheaper for them to get material from their old modules by like you break the modules and then you leach it and you can recycle the cadmium telluride back into a new modules. And since their technology has improved, they can make more than one module from an old module because they use a thinner thickness that produce more electricity. So for them, they've always recycle. And every time they announce, like they've announced 2 more plants in the US like last year, and all of the new plants they are building always have a recycling facility with it. So I just said that, so I'm not going to repeat it. But First Solar, I've been doing recycling. As I said, my postdoc was about looking at their recycling process and how to reduce the cost and the water usage. So they've been doing it for over 15 years. For silicon, I kind of already said most of it. So where does the concerns come in terms of like toxicity? So there are some concerns. There could be, well, there's a bit of antimony in the glass front, but it's tiny amount. But that's an issue for recycling the solar glass. In the back sheet, you can have like fluorinated compounds. So it doesn't necessarily mean PFAS, but that's a concern that there could be some fluorinated compound there. And the connection, how we connect the cells together, while it's similar to any electronics product, you usually have like ribbon, you have connectors, a bus bar. So in those bus bar, that's where you could have lead, but they're similar to any electronic product. There's also lead-free soldering elements now that, so it doesn't need to be used in solar. In the solar cell, similar there, like most solar cells, if they are high quality, they use silver for collecting the electricity. they are more and more moving towards like aluminum or other mix, but there could be like small amount of lead in there, but not all of them contain lead. And then the junction box is pretty standard. It's mostly plastic and diode and cable. So you have a little bit of metal there. So kind of the question everybody asks is like, so when will solar module reach end of life? So in the ideal case, you wanted to put it there and you remove them like 25, 30 years from where you take them. And that's one thing that has been improving quite a bit is like the warranty and how slowly they degrade. So like most warranty now are like 30 years, not even like 25 years. So we've made progress there. But like how quickly they will degrade depends on where you install them. So I guess the bad thing about solar panel is they don't love sun that much. So if it's too sunny and like a changing climate, they tend to degrade faster. Let's say northern climate like Michigan or New York State, that's good for solar. So they degrade slower than other climate. You don't also have like, well, unless you're closer like Long Island to the ocean and so on, then they might degrade a little bit faster, but those are climate that are pretty stable. You can also have just failure because of the design you choose, but the good thing is we've got really good at testing modules and like knowing which modules are going to be good or not. So there's a company called like PVEL that tests. That's what they do. They test modules. There's more and more tests every year, and then they will report which ones are top performers. So you know when you're purchasing like a module that is a top performer, that those have a better chance of lasting a long time because they have the fewer defects or they won't degrade as quickly as the other one. So otherwise, there's other things that could happen. Again, like some of those particular degradation mode, those are tested by those tests that have been developed over time. And then like one reason they get repower finally that it's harder not because they're not good anymore, it's just for economic reason. If one thing with much higher efficiency modules and lower costs is sometimes it has become better to replace the modules earlier than expected. But the good news is if those modules are still working very good, then they can be reused, and the reuse market and that what we call kind of repowering is increasing pretty quickly. So I'll get to that and give a few examples in 2 seconds about like repowering. The big concern generally about like waste is how much we're gonna have and like when. So that's some work we've done last year looking at like what would be the content and when will that really happen. So you can see neither like Michigan or New York are on those map where you have like the most state because we're not states where there was like early adoption and large volume of solar. So like the waste from the northern states are expected to get much later. And also like most of that waste is glass or aluminum that can be treated with traditional recycling methods. So look at specific waste regulation in US, I would say pretty much every state have been talking about like what to do with solar waste. Not a lot of states have established real rule. So like California is one where they've classified PV waste as universal waste. So not putting it as an hazardous waste make it easier and cheaper for like transportation, but also help it to get recycled. In Washington State, they've taken a different approach where they've put the producer and the installer is responsible for the handling and the post-customer PV module, but that regulation has kind of been stalled a little bit and it's a bit hard to be implemented. And I've put other example of regulation, but in most places, like for example, New Jersey, they just decided to put a commission to discuss it, but they haven't necessarily established any real regulation or how to handle solar waste at the end of life. So I mentioned like repowering. So this is something that is increasing really quickly. So I can give you 2 examples. So one of them is like Equitable Solar Solutions. So what they do is they are in Colorado, but operate a little bit more broadly. But what they do is they take solar panels from existing mostly commercial system, and then they evaluate, they test them, they make sure they still work. And what they've reported, that's from last year, that the average life of the modules they recycle was about like 12 years. and kind of the range was between 1 and 21. Why would you remove panels that are only 2 years? That could be just because you have like a defective roof or other things happening, but that's really not common there. And what they do is they test them, they make sure they still work, and when they work, if they still have like all the performance of a new, not new module, but like what it would be expected and no defects, then they can reinstall them on a roof. If they find some defect or efficiency that is lower than what they would expect, then they put it in a kind of a second use tier 2 application, which is not like on a roof, but like there's a lot of places where you could use solar indirectly for like I don't know, like a solar irrigation system that is not directly connected to a house or for like a community use. So that would be where they use it. And then the rest, they just dispose or and recycle of it because they don't meet the safety issue of the minimum for the module. So the thing is, it's pretty expensive to test all modules, but this is the big area that is, again, like growing quite a bit. Like DOE last year funded a big group of people to look more into like how to establish this second life solar market and how to make it safe, and by making sure there are regulation and testing protocol. Another one is like a Sparta, which is like in Tennessee. So this one is a bit different because they also repair modules. So like a lot of time what you can have is like an issue with like the junction box. So they would be able to go and like fix the junction box or repair. And like even like repair is something more and more common. Now you can go even without removing the solar module, you're able to go on site and repair the back sheet, and then it goes back and is okay for the rest of its life. But this facility, a lot of time what they need to do is they service a lot of if you have a large truck of solar panels and you get into an accident, automatically like those modules will not be installed. So those are still good modules. So they test them, for example, and then they're able to resell them. So a lot of time also same thing. If you have a large solar farm with a storm, even though like some part of the solar farm is not affected by the storm, because of the insurance, sometimes you have to remove all the modules. So like the modules that were not affected by the storm, they are tested and then resell in that secondary market. So that's just another example, but I'm just presenting those because I think that's good news that like a lot of the modules that are still good, there is more and more opportunities and interest in repairing, repurposing those solar modules. And then finally, if you don't have a choice, then there is recycling and there's more and more of it. So a year ago, I would have said about like 15% of solar modules get recycled. I would say now it's about 30%. And it really depends on like what state, mostly because of like where there are facilities or partner that exists. So this is from SIA. They've established like a recycler partner map. That's kind of the list of who participates to it. You have like all the circle would be collection places, and then it can be sent to one of those recycler partners. So the main one is SolarCycle, that is the largest recycler right now in the US, and the one that is able to separate most of the module. So what do you do with a solar module when it's done? So there's basically two approach. Either you try to disassemble it, you remove the panel, and then through either like a thermal process, like really breaking down the plastic, or what we call like the hawk knife method, you're able to separate the glass, like a straight glass panel with the rest of the material. And then you're able to either like reuse or get the material out. The other method kind of shred everything together, and then it's through like solution processing, you're able to separate the different chemicals there. But in that first method, you get like large amount of glass that is unbroken. So it shows broken here, but really it's a big sheet, so it's much easier to recycle. It's also not contaminated with the rest of the material. So this is higher value glass versus what you get from that shredding method. But like both right now exist in US. Okay, so what do you do with all those materials? You can recycle most of it. The glass, until now, the main issue is like you're producing a lot of glass, but it's low quality glass. In particular, people, if they're worried about any contamination from like metals, then that's not great. so it's a little bit difficult to return there. But the good news, for example, is like Solar Cycle has developed methods for glass. And yeah, I'm old and I have a kid, so I have to talk to people. Okay, I'll be right back. Okay, so the main thing is like for silicon, there's not really a good market for returning the silicon directly and making new solar cells. But there are opportunities and more work right now done to return like silicon into battery actually, as we are moving away from graphite to using silicon. That's a good application for that material. So there's been a lot of progress in recycling in the last 5 years, so that's really encouraging. And like the cost of recycling is going down, mostly for silicon, so that's encouraging there. So how we can encourage more second life or recycling. So that's one thing I talk about, like the EP criteria. So that's something that is evaluated. So if there is already design for end of life, or if the module can be easily recycled. Of course, if you have like solar waste policy at the state, federal, or local level, this is encouraging solar installers to think about like end of life. The cost of landfilling plays a big role. Michigan is super cheap, so it's like $1 to send a solar module to landfill versus $15 to get it recycled. So the choice is pretty easy for most people. So that's going to change if there's lower cost for recycling and higher landfilling cost. In terms of like what is that waste, that was published 2 years ago from Eder at NREL. So yeah, people talk a lot about solar waste, but if you compare it to other type of waste, this is a really tiny amount, even like in the worst case. So this is like what would be produced in 2050 versus like how much we're producing municipal waste. But and most of it's really not toxic, probably like a lot less toxic than your average municipal waste. It doesn't mean we should put it in landfill, but if you look at the scale of the waste of PV module, it's very small compared to a lot of other product that we're wasting every year. Okay, I'll talk really quickly about toxicity because I know we have time for a question, and I think I'm kind of over the 30 minutes, but how do we test for toxicity? So the main test is the toxicity potential leaching procedure, TCLP or TCLIP. People call it different things. So that's the main EPA method. How you do it, you break down the solar model in really small pieces. So 9.5 millimeter is really, really tiny. So I cannot think in any natural way a solar module would be that small. And then you put a really acidic solution there. And the EPA method tests mostly for those metal, not all of them, which is why there's actually like another method that is used, but only in California. That's probably the strictest method in the world in testing for toxicity. So that one is a different recipe in terms of like what is the pH and the size of particle. That's even finer particles, but it's also testing for other chemicals like zinc or copper that are not included in the EPA method. And if you want to send a solar module for recycling, it needs to have passed the TCLP method. And every manufacturers of solar I've talked to done the TCLP. That's just like a more normal thing now. So a few years ago, APRI and other scientists kind of developed a standard method for sampling solar modules, because like where you're taking the sample really matters, because like you don't have uniform distribution of, if you have mostly lead, as I said, mostly where we put lead is if you like when you connect all the cells together, like you'll have like a bus bar, that's where your lead would be. So if you take like a sample right in the middle of your cell, you're going to get silver, but you're never going to get like the lead or something. So they develop a method where they say where you should test like where to get different samples, and then how to get all those things. Sorry. So that's one test. In my group, we've done other type of method. For example, like you can do that. We also like do like full digestion. So I take a full solar modules, and as it says, like I digest it in acid to get like the full total method content, and check like how much gets would leach in other condition. And also we did a comparison, like doing like a full landfill study. So we did put like silicon modules there, but also like different products we could buy online, including like battery, power tools, phone replacement battery, to check like how they would compare. And what we found is in general, like many common electronic product will be considered like hazardous waste and don't have any notice on it. So like solar modules in general, like there's only one we found that had some lead, and this concentration was pretty high compared to like a more modern type of module. So EPRI has done more of this kind of data, and they're building this database. They don't like report what module itself it is, but they've compared over 33 different PV modules so far, and taking like a lot of different samples. And what they found is only 3 of them would have failed the test, and all of those 3 were like field age, so older modules. So only like 3 out of 33 contain lead. All the other ones didn't contain any lead. So it doesn't mean no solar panels contain lead, but if there is, it will be a really small fraction of it, and it's more likely it's going to be old modules, because all manufacturers now are aware that people don't want lead in their solar modules, so there are a lot of alternatives they can use instead of that. I do a lot of other tests in terms of like toxicity. So I do acute toxicity. We do like column leaching. We do like landfill and so on. And I've done quite a bit of work on PFAS. I wish I would have done more because there's a lot of question, but that's a difficult question to answer. So talk about PFAS. Like PFAS, why it is so hard to address is because it's not one chemical, it's a full class of chemical. So and when you're trying to test for PFAS, it's easier if you know what you're looking for. But if nobody disclosed what they might have used in solar panels, it's really hard to establish like new methods for testing them. So pretty much anything that's like long chain of carbon with fluorine on it is one kind of or another of like PFAS. So it's really hard to figure out if they are or not there. The other thing in a solar farm would be that a lot of other products might contain PFAS from the construction phase that is not necessarily the module. So excluding what is the source of PFAS is a bit hard. In particular, like in construction, if you have like leather boots or a lot of the things you're wearing, or even like the cables, it's very, very hard to figure out where the contamination would come from. So we recently published this paper, like doing like a full literature review about like what we know about PFAS in solar modules, and kind of review like where, because they are mentioned, but there are no clear indication of if they are used or not. Like most of the time when they are mentioned, it's like a lab scale study. So it's not because you try something in a lab that it actually been used in a real module. And if we find some that might have been used in solar modules, they are usually like fluoropolymers. So they are the one that are considered like lower risk PFAS there. So what we did for this study, we took like the worst case scenario for all the PFAS that were mentioned, and then look at like how much concentration there would be per kilogram of module, for example. And then there is like for each type of PFAS, you have a certain hazard that is associated with it. So what we found from this work, like in the worst case scenario for solar modules, we see that there would be no risk because like they would be in really, really small concentration, and it's mostly PFAS that are non-toxic that would have been used, and mostly in like in the backsheet or in places that are unlikely to leach there. But overall, we shouldn't get like those chemicals to leach or end up in landfill and so on. So if we kind of recycle those modules, then that kind of address 2 issues, like reducing our waste, but also address the toxicity concerns there. So not gonna repeat everything I said. I think I talked over, so I prefer to keep some time for question about anything related to like the environmental impact of solar construction, in particular the modules. Thank you.
All right, that was great. Thank you so much for all that information. I don't see any questions in the chat, which surprises me, but if anyone has questions, please put them in the chat, or go ahead and unmute yourself and you can jump in, or put your hand up, perhaps, that I can see you that way. But I have one question just to kick us off. One of the things that we hear a lot about is if the panels are just in the field, in the solar farm, and they are damaged by hail or some other thing damages the glass's integrity, what can happen in terms of the leaching of any kind of toxic chemicals into the soil or into the groundwater? What kind of things might happen, if anything?
Well, um, well, it's very unlikely that anything would have, like from the module itself, you mean, or from anything else in this system? Yeah, people are really worried about the module, but like the way it is constructed, like it's mostly glass and then you have everything inside. So like the likelihood of anything inside that might contain in a really small amount lead to leach is almost impossible. So the only way it would really leach is if you have like a solar module that is like broken enough and then you don't have the plastic piece that keeps everything together that would let the chemicals leach out. But those like those metal, they don't want to leach out unless they are under like acidic. So you need to have like acidic rain with like a completely broken module that is left there for a very long time. And like in a solar array, there's no reason if you're producing electricity, so why would you leave like a broken modules on site? Like normally, like if you're producing electricity, as soon as it's not working, you're gonna repair it, you're gonna replace it. You'll see like it's not producing anything. So there's no reason why you would have like a completely broken solar array module on site. So it's very unlikely. But we've tested that for both like cadmium telluride or like silicon, and they don't really leach just because they are pretty stable and everything kind of gets stuck in the plastic layer that you have there.
Mm-hmm. Okay, thank you. Any questions from the group? David, I think I saw a hand.
Sure. Thank you so much for this. I think a lot of people have been very interested in all of these topics that I've talked to over the years. Could you just clarify how what you just said about cadmium and lead would or would not apply in terms of leaching concerns or runoff concerns regarding PFAS, which you said is hard to track, but just conceptually, is there a different kind of risk of that those chemicals being a problem in relation to sort of the panels just being out there in farm fields?
Yeah, so like there's no clear indication that there is PFAS use in solar. And the main reason why, and I mentioned like the NSF standard, like the EPEAT standard right now, we're kind of reopening. So one piece of that would be to require solar manufacturers to disclose if they are using or not PFAS, because like the first, like when that was created, there was no requirement for doing that. So if there is PFAS, as I showed by like kind of the impact factor, like the risk would be really, really low, because those that are used are they are mostly fluoropolymers. They are not like the class that are that we really worried about. And the way they are used is if they are used, they are used for preventing like soiling, and like manufacturers, they know there are alternatives. So for the like if you're doing like a silicon modules, you prefer to have everything based on like silicon. That's just easier to keep the same like starting materials, and there are better working silicon material for solar panels. So so that would be the main thing. So I think the easiest way of addressing that is to require solar panels to show that they didn't use PFAS in their manufacturing. We don't have that standard or that certification in the US right now. They just released it in Europe because there are the same concerns. So there's more and more efforts now to certify, like that's kind of a way of selling your solar modules that you can claim that you're PFAS free, but it has not been requested in the US, so solar manufacturers won't do it because of that.
I have a related question, I guess. There are some questions in the chat, which I will get to, I promise. But a related question is, has your lab done any sort of pre and post testing on sites that before construction of a solar farm and after construction to see what kind of contamination is on the soil before and after?
We're doing it right now. So it's been hard because we're building something in Kansas with farmers, and then we got approval from it. It's not that I haven't asked, but it's been really hard, mostly if you're like a large developer, because I guess maybe it's just Michigan, but they want to protect themselves, so they don't necessarily want you to find something and then add issues. So they don't been really supportive of sampling, but that's something I'm doing in 2 sites right now. But like the thing with PFAS, you find PFAS everywhere. So like if it's more than your background, it's really hard to test like the after effects. So I've been looking more into metals, and that's what
Oh, we lost her. Oh, she's back.
Oh,
Um,
I'm still there. I'm just dealing with the I
Dealing
can't.
with sound. If you have to step away for a minute, that's fine. We have some other questions that are for Jason. I don't want to cut you off though, if there was more you wanted to say there. We'll get back to it. Jason, there's two related questions. Does Ag and Markets consult on utility scale projects? And also, does your group consult on projects 5 megawatts or less? So at what scale does Ag and Markets get involved, and is it, what is your involvement on the small and the very large projects?
Sure. We have two programs in New York State through NYSERDA. And it's two different funding mechanisms. And one of the smaller scale solar programs is called New York Sun, and that's typically your 5 megawatts or less. And that's the predominant population of our notice of intents. So that's a lot of our reviews under that program. When they get to the large scale renewables, greater than 25 megawatts, we serve as a consulting agency to the Office of Renewable Energy Services, who now permits. And historically, we were a statutory party under a Public Service Law, Article 10, where we file testimony and so on. But we are involved on all of those cases. But below 25 megawatts, typically we are limited to the agricultural districts.
Thank you. If there's follow-up on that, please drop it in the chat as well, for whoever asked it. I'm not sure I quite understand the question, but there was a question about, I think this is for Annick. Does the glass break due to nickel inclusion? So maybe if nickel is part of the mix in, I'm not sure where it would be, but does it affect the glass is a question.
No, I haven't heard issue about that. There's more glass breakage now because one reason why we're getting cheaper modules is because we've reduced the amount of materials that are being used. So like modules have gone like bigger and bigger, but also like the amount of glass has gone like much thinner. So in the last 2 years, been a major issue about like the glass breakage from solar panels. So actually, like solar manufacturers now are going back into like thicker modules or, yeah, more tempered, harder glass. So it is important in certain climate. That's something we realize. Michigan gets a lot of hail, so that's one of the way glass would break is because of more storms than because of other reasons. So it's just what breaks them.
Great, thank you. There's a question about, or more about recycling. There's a company in the US that recycles 90% of the parts. I'm assuming the components. Are there others coming up? I know you mentioned a few, one in Georgia that just recently opened up. If you can address, kind of the forecast for recycling in the future.
Yeah, so I would say like recycling 90%, it's easy because 90% is mostly just the frame and the glass. It's hard to get above like 95%. So that's also, like I mentioned, like the SIA standard we're working on right now for recyclers is exactly about that. Is like to distinguish between like people that take the modules and just dismantle like the junction box, the frame, the glass, and most of it still ends up in the landfill. So I would say add on my slide, like all the SIA partners, like all of those companies can do the 90%. Like the one that Solar Cycle can do the probably like 98, 99% of recycling. The only thing they don't really recycle is the EVA, the plastic in between your glass and your cells, because that's really low value plastic. But they are kind of the leader right now here, but there are other companies that are trying to compete with similar methods. I would say in Europe, there's a lot more company, and they've been around and doing research in that field for like, they are probably like 5 years older than us on methods for recycling.
So that really speaks to the recycling of a single panel or a batch of panels. But do you have a sense of how much of the total quantity of panels is being recycled, either in New York or in the US?
As I said, we think right now it's hard to track, because those like solar panels don't need to be tracked because they are not like hazardous materials and they don't get so. But like from survey IPRI and Enreal has done, they think about like 30% now get recycled. And that goes higher mostly if you have like silicon modules with like a lot of that frame, or older modules contain silver. Like the value of solar modules over time is going down. So as we replace silver with aluminum contacts, then like who will want to recycle that will go down. But like the 30% is the estimate. But like in Europe, like in France, for example, it's because they have an organization called like PV Cycle in Europe, like about 90% of solar panels get recycled. So like there's a huge difference that is pushed by policy, and that well, I was just at a conference last week about PV recycling, and that's what the French model is really what has worked the most, because like when you buy a solar panels, you put a deposit on it, so that pays for research and establishment of recycling facilities and collection. So there is really no reason for, well, you're not allowed to put it in landfill, but also like the infrastructure is all there. So.
Mhm. Thank you. And in terms of recycling, is staking on that just for a minute. Is there any policy? Are you aware of anything that can be done at the local level to encourage recycling or even reuse, like you talked about earlier?
Yeah, so I think that's part of some of the like for example, Solar Cycle Law, they are successful right now is because they sign agreement with developers. So it's part of the developer when they put a plan together. There is, as part of their plan for end of life or dismantling, there is kind of an agreement already about the recycling. So it's part of the contract before the site is even built. So the same way you have like plan for returning the land to its initial state and everything, you can put condition there that states that you're going to recycle it. You're not allowed that to go into landfill. So that can go into local level.
Excellent, thank you. Looking at the chat again, what size hail will damage a solar panel? I don't know if that's a
Yeah. Yeah, so like bigger hail. So you normally, if you get like higher than half an inch to 1 inch, and that happens, I don't know, in Minnesota and Michigan, that happens quite a bit, it seems like in recent years. So yeah, those are bad. So anything, usually we say like the golf ball is the worst size for a solar panel.
Okay, yeah, and we are seeing more of that. Question for you, Jason. I'm not sure I get it entirely. It seems like it might have gotten cut off. So if you want to chime in, Candice, what is your group's position on ag land situated under kilovolt lines, so transmission lines, and how much coverage is an acceptable amount to reach the state's goals?
Interesting. It just doesn't happen.
What doesn't happen, Jason? You don't have a stand, or it just gets to be whatever the state wants?
Well, I mean, I think it's a safety issue, to be honest. There's clearance standards for transmission lines, and I think we have challenges with when I used to work in consulting of what type of land use is under the transmission lines and what is an acceptable use. Typically, the transmission lines have a setback from any development. You can't even have garden sheds for crying out loud. So when you have a metal roof that can convey stray voltage as well. So if you have these panels that are covered in aluminum with with steel infrastructure holding them up, there's that potential that stray voltage could be a concern. Especially with when you're reaching like 115 kilovolts or more. So it's really not an ag and market thing. It's more of a Department of Public Service. It's not allowed. So I think the setback is 80 feet on a transmission line.
Okay, so with that, I'm in a community where we have those KV lines running through, so I'm in Genesee County.
Oh, yeah.
Okay, so yeah. So I don't know where the stand is on that and the amount of ag land that is being swallowed up and with a position at the state level. Just don't know where the local municipality can step in as long as we have large scale farmers that are willing to give up their land for land leases.
Yeah. It's
So
Genesee
is there any
County.
pushback from ag and markets? I guess I'm just trying to get my head around different things in our community.
Yeah, you're in a tough boat right now.
Okay, that's what I want. That's exactly what I wanted to know, I guess.
Yeah, Genesee County is currently dealing with one of the largest solar developments in the state. In parallel, Cider Solar is 500
Okay.
megawatts, and then you have a parallel. I think that's a couple
Excelsior.
hundred megawatts. Excelsior, yes,
Which
and
is
then,
280, yes. And that's the town I'm in.
and I believe you have also a series. I want to say 9 or so smaller developments surrounding them, and they're all within 3 or 4 miles of each other. And then there's another large scale just going up. Is it Ontario that's above you? Or Orleans?
No, there's one in Alabama that's site. Anyway, I'm just reading this the KV lines and trying to see, all of it is sited underneath, a lot of prime farmland, and I just didn't know.
Well,
And
we used to be able to say, our piece and testimony, and now we don't have a whole lot to say except of how are they in compliance with our construction mitigation, and if there's problems there.
so in the
then we
utility
identify.
scale, just a quick question, because we're not a 94C, we're an Article 10 project. So
Yes.
is Ag and Markets diligently overseeing the project
Yes.
on the ground?
Yes, I have staff on, the same staff member on both those sites.
Okay,
And, I get reports on how things are going.
all right. No, I just was
Yeah.
chiming in, so.
Yep. Yeah, on the large scale facilities, and I call them transmission scale,
Correct.
we have compliance staff, and then we work directly with Department of Public Service on any kind of non-compliances that we may see. So we work hand in hand.
So at the local level, are those reports viewable, reportable to the local municipality for our own records, or is it a moot point at this point for such a large project?
I don't think they are. I think that unless it gets to a violation phase, we had recently a development south of Genesee that got into some stormwater problems, some drainage into a trout stream, and that reached violation where they were penalized monetarily, and that got out, obviously. But when there's not non-compliances, they have the opportunity to fix things that's not publicized.
Okay. Thank you.
Sure.
Yeah, thank you. We do have one last question I'll address here. I don't know if anyone has an answer, and if not, I will follow up. Are you seeing any cases of mastitis in dairy cows related to stray voltage? I can look into that one if neither of you have any information. I know that there are cattle grazing under and around solar panels directly. We're not talking high voltage transmission lines. We're talking solar arrays, but they don't seem to be suffering. They seem to be doing quite well with higher milk production in a lot of cases probably because of the shading, cooling effect. So anyway, Jason or Annick, want to take that one, or we can close for the night?
Yeah, I would say as far as the shading goes, that's something that we're exploring, and we anticipate that is going to definitely reduce heat stress. Encouraged with that if industry would go to that standard, but it's a more costly development. As far as mastitis, I haven't heard that. We've talked about livestock stresses with wind farms, and that really hasn't been proven either. But I'm not going to say that it doesn't either. You know, I just have no information.
Okay, thank you. All right, with that, I know there's some more questions, but we're gonna have to close it up. We're about 5 after. Thanks everyone for joining us. Thanks for staying a little bit late, and thank you especially Annick and Jason for the great presentations. I will be sending out a link to the recording to anyone who's registered, following up, and be sure to register for sessions 3 and 4 coming up next week and the week after, on first responder concerns and on community benefit agreements and pilots and things like that, is week 4. Thanks, everyone. Have a good